This innocent-looking integral has a beautiful result, but to reveal it we'll have to do some unintuitive manipulations. Start by splitting the integrand into two products like so, and then times the top and bottom by e to the minus x. Now some of you may be able to recognize this as a geometric series with a common ratio and first term of e to the minus x. We will put this back into our integral and tidy up by doing a little reindexing of the summation. Hand-waving convergence, we will swap the order of the sum and integral, and now it's time for us to make a substitution. Let u equal nx. Following this, we can see x equals u over n, and dx is equal to du over n. N is positive, so with the bounds unchanged, we can make our substitution. N is a constant with respect to u, so we will pull n squared out behind the integral. We must call upon another function, the gamma function. More specifically, we can see that our integral is gamma of 2. We will now use the property that gamma of z is z minus 1 factorial to say that gamma of 2 must be simply 1. As we can see, all that remains is the sum of reciprocal squares, and thanks to Euler we know this is pi squared over 6. Thank you so much for watching. If you got this far, consider liking for more integrals, and I'll see you in the next video.